Hi students, good morning to all. Today in this video we are going to discuss the third concept of second chapter of third unit. The concept is language features for programming in the large. That means for the large programs, for decomposing those large programs into smaller individual units, nothing but modules, what are the different language features provided by different languages. So about these things we are going to discuss in this concept. For this, what are the points provided by your concept is all programming languages provides features for decomposing programs into smaller and largely autonomous units. So all the programming languages, they're providing different features for decomposing the programs into smaller. So complex large programs will be divided into smaller. All the programming languages provide this feature. So we refer such units as physical modules. So that smaller units in all the programming languages are referred as modules. So we will use the term logical modules to denote the module identity identified at the design stage. So in programming languages, dividing the complex large programs or decomposing the large programs into small units, we are saying as physical modules. So we can use a term called logical module when it means the module is identified at the design stage. If the module is identified in the design stage, we can say that module is logical module. In the programming environment, by using the programming language features, if we divide the program into smaller units, we are calling that one as physical modules. The what are the relevant aspects of each languages are given in the following points. So based on the relevant aspects for each language, what they are providing for this decompositions means first one, module encapsulation. So first relevant aspect for each language providing for modulation is module encapsulation. I think we already discussed these things, the concept supporting the modularity, same format, same type of concept, similar concept may be available here also. So the relevant aspect for each language providing for modularity is first point is module encapsulation, and the second point is separation of interface from implementation, and the third aspect is program organization and module grouping. So these are the aspects for each language are must and should follow in the decomposition of large projects. So those are nothing but module encapsulation, separation of interface from implementation, and program organization and module grouping. So with the help of these things, we are applying these aspects in different languages. In that series, the first we are going to discuss about Pascal. In Pascal, how this concept is implemented. So the only feature provided by Pascal for decomposing a program into modules as procedures and functions. So in Pascal language, so what is the feature provided by this programming language for decomposing a program into modules means only feature is procedures and functions, which can be used to implement procedural abstractions. So with the help of procedures and functions, we can implement the concept of decomposing a program into module with the help of procedural abstraction. So in Pascal also, we can decompose a program into modules with the help of procedures and functions. But because means already we discussed, Pascal supports procedures and functions. So with the help of that, we can decompose the programs into modules. So now we are going to discuss the Pascal program structure. So the Pascal program that means the procedure structure maybe look like in this format: program name, nothing but a file, and the declaration section is there. There we are need to declare our data types, variables, procedures, and functions. Everything you need to declare here. And after declared, the concept, the program is begins. So in the after beginning the program, so whatever the statements you need to write here, we can write here, and finally we can stop the concept. So this is the program structure of Pascal, but this structure we can represent in the form of diagrammatic representation. The organization of Pascal program is thus a tree structure module of modules given below. So how we can divide the Pascal programs means in tree structure modules. So when you want to decompose the large programs in the Pascal language, it is possible only in the form of tree structure of modulation. The tree structure of modulation is given below. So in this format, for example, part A is related to part B and C, D, E, F, like this, a simple representation tree structure given here. In this format, we can divide the Pascal programs into modules. So for that, the structure, what is the structure they follow means tree structure of module format will be followed. So this is the concept behind Pascal. So Pascal also supports modulation. It is how it is followed means with the help of procedures and functions. Then the second language, which is nothing but we are going to discuss, is in C language. In C language, how this decomposition of programs are possible, how this feature is implemented means in C language, C provides functions to decompose a program into procedural abstractions. So C language supports only functions. So functions means they return value. Procedures means they does not return value. These types of concepts we already discussed in our previous concepts. So C supports functions to decompose the program into procedural abstractions. So in addition, it relies on a minimum of language features and a number of conventions to support programs in the large. The programs are large. In addition to decomposing the program, some minimum number of features are also provided and number of conventions also supported by C language for managing the complexity in large programs. Then C language units of physical modularity is file. So in C language, if you divide the complex programs into small units, those physical modules we are saying as files. So the files, if you divided that programs into files, how you can make the interaction between them is with the help of interface. But in C language, those interfaces are called as header or include files, are used to resolve the inter-module references at compile time. So for one module to another module, if you want to refer or if you want to communicate means, to communicate you must use compulsory an interface. In C language, those interfaces are called as header files or include files. So in C language, hash include stdio.h, hash include conio.h, like that we are including some files. So we are calling that files are nothing but header files. So with the help of those files, we are resolving the problem of intercommunication references in modules in C language. So those interfaces called as headers or include files. These files are used for the resolving of inter-module references at compile time. So C language is also support decomposing of programs with the help of functions. So those decomposed small units or modules here in C language will be called as files. So between the files which will act as an interface means headers or include files will act as the interface at the compile time. And a small example program to explaining the decomposition concept in C language. So how the decomposition concept is explained in C language means with the help of functions. So in this program I am showing some small functions. So here I taken a file called stack.h, declaration exports to clients. So what are the entities we want to export to the client? So it will be declared here. and a small function is declared in a structured manner. Structures. So type that struct. Struct means we are using structures, and the structure name is stack. So a small function will be implemented. So in that we are declaring some variables, element, array element, and integer data type, and top integer. So that function is closed. For that we are declaring the objects. So in void push object, push function and top function will be declared. So end of that stack. So this function, this is one of the unit or one of the module of the program, and the second module is stack.c. So another file will be designed, the implementation of stack operations. So for that we are including that stack.h header file. So to interface the stack.c and stack.h, we want to use this interface. So this include will act as an interface between this file and previously saw files. So in this file we are declaring the push function, and for that what are the elements will be required, they will be given here, and a top function, what are the files wants to statements wants to declare will be declared here. So this is the end of the second file, that means second module, and these two modules we want to use in the main file. So when you want to implement, to run the concepts, you want to call all these files in the main. So a file called main.c, and we are including all the header files for interfacing. So include stack.h is an interface, then main function will be start here, and we are calling the structure name as struct, and we are declaring the two objects for the struct. With the help of these two objects, we are calling all the functions what we are declared in the previous files. So s1.top, you already declared this top in the second file, and for this function we are declaring. Then push in the first file, we are calling all these things here. Okay. Then pop, we are already declared in here. So all these things will be called in the main function, and we are executing that. So all these statements or files you want to write in the main program, it may look like as a very large program. So to avoid that large complexity in the main program, we are dividing that one into small modules. Those modules in C language we are calling as files or functions. With the help of functions we are making that modules. Those modules we are saying as files in C language. So two modules are there, two files are there. Those two files we are calling in the main function. So if you write those files also here, then how much lengthy it is. So to avoid that one, we are divide them into small units. So this is an example program for C language to explain the modularity. Then we are going to discuss the next language is C++. In C++, how they are supporting. If C++ also supports the development of independent modules, but it does not enforce it. So how? So C++ also supports independent modules. How means? With the help of different concepts. In that, the first concept is encapsulation in C++. Already we discussed what is meant by encapsulation, nothing but wrapping up of data. How it is possible getting together all the elements in C++ means with the help of classes. So the unit of logical modularity in C++ is the classes. So in C++ is a pure object oriented program. So how we can keep all the data together means with the help of classes in C++. So a class serves several purposes, including first one. So for the class, it supports different concepts. What are those means? First one is a class defines a new data type. That means user defined data type. Class can define a new data type, nothing but user defined data type, and he can able to define encapsulated units. So class providing these services in the encapsulation environment. Then entities defined by a class are either public. So in object-oriented programming, the concepts which we are declaring, whether we have three types of concepts, one may be public or private or protected. So entities what you are defined in the class, either public, exported to client, so it may be accessed by any client, or otherwise if you declared or defined as a private, it is hidden from the client, it may not provide to the client, or you may provide protected variables. So these are the three different access specifiers are available in object-oriented environment. So whenever the entity is defined by the class, they must either in public or maybe private or maybe protected environment. So this is the concept we discussed in encapsulation in C++. Then what is program organization in C++? Means how these programs will be organized, means with the help of classes defines the abstractions from which the program is to be composed. So how the program was to compose, it will be discussed in the classes. So in C++, so the programs are organized with the help of classes. The main program or a client create instances of classes and call on them to perform the desired task. So classes will be designed based on the classes objects will be declared. In the main program, the client create the instances for the classes, nothing but client create the objects to the classes. If you call them, it performs the desired task. So in C++, we are organizing the programs in this manner with the help of classes and instances, nothing but objects created by the client. So in this manner, we are organizing the programs in C++. Then how we are grouping of units in C++. So grouping means nothing but indirectly we can say encapsulating the modules. So C++ has several mechanisms for relating classes to each other. So different classes, how you want to relate them means C++ have several mechanisms. In that, the first mechanism is classes may be nested. So one of the relating classes mechanism is classes may be nested, and second one is by using friend functions and namespaces. So with the help of these concepts, C++ can group the units. So this is the concept of grouping of units. So in the same manner, we can implement the other languages also. Languages like Ada language and language like ML. So how we are implemented the concept of C++. So what are the concepts we discussed in C++ implementation for decomposing the program? The same manner we can implement these languages also. Same concepts will be applicable to these languages also. So in this concept, what are the points we need to remember means, so when you are decomposing the programs, large programs into small units, different languages are providing different features. So based on that, what are the languages are discussed to providing the features? In that, first we have discussed the language called Pascal. It supports the decomposition of programs with the help of procedures and functions. Then C supports the decomposition of program with the help of functions, and C++ also supporting the decomposition of programs with the help of classes. So in the C++ we have some concepts called encapsulations and grouping of data, etc., etc. So all these points you need to remember in this concept. Thank you.